Okay, hi, my name is Elliot, and I have homework number 1 and question 28. Okay, so a sound wave with intensity 2.0 times 10 to the negative 3 watts per meter squared is perceived to be modestly loud. Your eardrum is 6.0 millimeters in diameter. How much energy will be transferred to your eardrum while listening to the sound for a minute? So I just drew a little diagram for fun. It's just a sound source traveling to our ear, which is 6 millimeters in diameter. And we just want to see how much energy will be transferred within a minute. So the first thing we want to do is write down our knowns. So our first known is intensity, which is 2.0 times 10 to the negative 3 watts per meter squared. And then we also know the the diameter, t equals 6.0 millimeters. And we also know the time, which is t equals 1 minute. And what we are looking for is how much energy will be transferred, so E equals question mark. So with E, what formulas we get on our sheet is P equals E divided by T, and with simple algebra, we multiply T over here, and so we get E equals P times T. Okay, but then we also don't know what P is. And so what P is in another formula is I equals P divided by A. And if we do algebra again, we get P equals intensity times area. Okay. And so now, going back to our original formula, E equals P times T, we can replace P with IA instead. So we get, I'll write it down here. E equals IA times T, which is also IT, because area is pi r squared, correct? Yes. So our final formula for E is E equals IT times pi r squared. And all of these we know, I, T, pi, and then r, which is radius, is just distance, or our diameter, so it'd be 3 millimeters. Okay, so now we just plug in all our knowns. And so we get E equals, I'll just rewrite the formula one more time. Pi r squared T equals 2.0 times 10 to the negative 3 times pi times 3.0 times 10 to the negative 3 meters. And it's 10 to the negative 3 because we transferred millimeters to meters, and diameter is not, the new radius is now 3 times 60 seconds. So we plug that into our calculator, beep boop bop boop, and we get E equals 3.4 times 10 to the negative 6 joules. And so that is how you solve this problem. Basically, you're just doing simple algebra to basically remove the variables and just find the new variables with using different formulas. And something we could take away from this maybe is that if the distance or the diameter of the ear was bigger, for example, let's say like a meter, let's just say, it definitely would absorb more energy because of the distance was bigger or the diameter. Okay, thank you for listening. Goodbye.